All right, so we are kicking off our unit on vectors. A vector is a quantity represented by an arrow with both direction and magnitude. If you missed this class, you can watch the Despicable Me clip on Canvas. So we have our unit vector denoted by an I, and that is equal to the horizontal unit vector. And so our vectors are written this way. It's like a little pointed parentheses. I don't know if that symbol has a name, honestly, but that's how it looks. And then we have another unit vector, which is a lowercase letter g, and that is our vertical unit vector. The components are 0, 1. So if we look at the graph of our unit vectors, unit vector I just says go 1 unit horizontal and 0 units vertical. So the horizontal unit vector I starts there at 0 and goes to here. Now with vectors, we put an arrow at the end. Now this is very different than linear functions. When we're graphing functions, we put an arrow to show that the function continues indefinitely, like it goes on to infinity. With vectors, the arrow doesn't mean that it keeps going. It actually stops at the point of that arrow, but the arrow is there to indicate the direction, okay? Because a vector that starts here and goes to 1 is going to be entirely different than a vector that would start to 1 and go to 0, okay? So the arrow part of the vector is giving you direction. So this is the unit vector I. And then if we were to go up 1 unit, like this would be our unit vector J. 0 units across, 1 unit up. So unit, because uni means 1. So I can take a vector V, and I can write this vector in 2 forms. I could write it in our linear combination form, 6i minus 6j. And what that would mean is 6 multiplied by this unit vector, so it would mean 6 units horizontally and 0 vertically, and then minus 6 times this vertical vector, so I would be going 6 units down. But the other way to write vectors is what we call component form. And for that, vector V would just be the components. 6 for the horizontal component and negative 6 for the vertical component. So that's one thing in terms of notation, is being able to know the 2 different forms of writing a vector. So linear combination form here, component form in this case. All right, so direction and magnitude of vectors. Well, sometimes they're very simple. So sometimes your vector might just lie on your axis. So I could have a vector that's right there. Let's call that vector K. So if I were going to write vector K, see that vector K is negative 2 on the horizontal, so it would be negative 2i And it doesn't have a vertical component. The vertical part is 0, so I wouldn't even need to put the j at all. Or if I were to write that in component form, it would be -2, 0. Now, the magnitude of a vector is the length of a vector. So my magnitude of this vector is just how long is it? Length isn't determined by positives or negatives. So that vector, the magnitude, is 2. It's 2 units long. And when I say the direction of my vector, I'm talking about the angle. So the directional angle, we'll use theta. And we're going to measure our angles the same way we did in trigonometry. So if I start on the positive x and I go around to this angle, how many degrees is that? 180 degrees, right? If you've forgotten everything, you can look at your unit circle on your yellow paper. That is 180 degrees. And when we're dealing with the vectors, we're going to use degrees instead of using radians. All right, so that's your basic idea behind magnitude and direction. So what if I had a different vector? Say that went up to there, but you can't see that at the screen at all. 1, 2, 3. Let's call this guy vector W. So I'd take vector W, and I could write it, well, it doesn't have any 0 component, so it'd be 0I, so I won't even write the I. And it's going up 3 units, so I could write it as 3J. If I was going to write it in component form, it would be 0, 3, right? Because 0 is my horizontal component, 3 is my vertical component. What's the magnitude of this vector? Magnitude is 3, that's its length. And then what would be the directional angle of the vector? 90 degrees. Well, there doesn't seem to be anything too difficult about that, right? But our vectors don't always lie on our axes. So let's go back and consider this vector v up here. Let's draw where that vector would be. So my horizontal component says to go positive 6. 1, 2, 3, 4, 5, 6. And then from there, go vertical 6 down. So again, I'm dealing with vector v, which in component form is 6, -6. So then that means I'm starting at 0, 0, and I'm ending right here. Because I went 6 across and 6 down. So this right here, starting my initial side, and then my terminal side with the arrow, this is vector v. So what's the magnitude? I can't just count like I did before, right? because now my vector is at a diagonal, right? It's not just going horizontal or vertical. But do you see that that vector is being formed from a right triangle? You see that that vector is the hypotenuse of the right triangle? So if this leg is my x, because it's my horizontal distance, and this leg is my y, and I do the Pythagorean theorem, x squared plus y squared equals this hypotenuse squared, then if I wanted to know the hypotenuse, I'd take the square root. So to find the magnitude, and we write magnitude like this, the letter V, and it has two little lines here and two little lines here. Kind of looks like a double absolute value. It's just going to be the square root of x squared plus y squared. It is going to be the Pythagorean theorem. Because we are measuring the distance of this hypotenuse. So for this particular one, the magnitude of V would be the square root of 6 squared, because that's my x value, my horizontal component, plus a negative 6 squared. All right, so just a reminder, when you square a negative number, you need to put it in parentheses, so that because you're squaring that entire value. But now here's the issue. If I press all this into the calculator at once, 6 squared plus parentheses negative 6 squared, it's about 8.5 if I want a decimal answer. But oftentimes, we're not going to want a decimal answer. We're just going to want a simplified radical answer. So if I do 6 squared and negative 6 squared, that's going to be 36 added with 36, right? That's going to be the square root of 72. See, that's that same decimal, square root of 72. But I need to simplify a radical. So remember, to simplify a radical, you're thinking, what is the largest perfect square that is a factor of 72? 4 goes into 72, that's nice. 4 is a perfect square. 9 goes into 72, that's a perfect square. But 36 is a perfect square, and 36 goes into 72. So I want to take the number 72, and I want to factor it into 36 times 2. The square root of 36 is 6, and then I leave my square root of 2. And then if you just wanted to check that that was equivalent, you could do 6 times the square root of 2. And yes, it's that same decimal, 8.5. But this is written in simplified radical form. So again, we're just simplifying that radical. So a reminder about perfect squares. Two squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36. Those are like your main ones. If you're trying to simplify a radical, you'll want to remember those perfect squares. Alright, well, let's talk about finding the direction for this vector, because vectors have direction and magnitude. So when we're asked to find the direction, we're looking for theta. And theta is the directional angle that starts on the x-axis, and we measure the angle counterclockwise. Same way we've been measuring angles all semester, right? So this is our theta. Just remember, theta is measured counterclockwise. Well, here is where some trigonometry comes in. Because if I want to know this measurement of theta, I got to operate from something I do know. So I know that my tangent is sine over cosine, and my sine is y, and my cosine is x. So tangent of theta is going to equal sine of theta over cosine of theta, which is going to be y over x, which is going to be -6 over 6. Because -6 is my y value right here. +6 is my x value for cosine. And remember, this is just coming from, if this is my angle, this is opposite SOHCAHTOA, this is my opposite, this is my adjacent. It's all connected. So -6 divided by +6 is -1. So this is where you're going to use your unit circle. And where is the tangent going to be -1? But look, you're down here in the 4th quadrant. You already know it's down in the 4th quadrant. So down here on the 4th quadrant, where is the tangent going to be -1? 315 degrees. So that's our theta. So, if I were to start here, go around 315 degrees, that gives me my direction, and then travel out 6 times the square root of 2, and stop, that gives me vector V. It has direction and magnitude. Alright, so let me give you one to try. So I'm going to give you a vector. We'll call this one vector U. And it is going to be written -7I minus 4J. Now, we can write that in component form. -7 is our horizontal component, and -4 is our vertical component. So go ahead and find the magnitude and the directional angle. So our magnitude was pretty straightforward, square root of 65. For our directional angle, I'm just going to go ahead and sketch very quickly. It's -7, 1, 2, 3, 4, 5, 6, 7, and then down 4, 1, 2, 3, 4. So this is vector U. So this is my angle. So I know that my angle is in which quadrant? Third quadrant, right? Quadrant 3. And what's the degrees right here on the negative x-axis? 180. And what's the degrees here on the negative y-axis? 270. So if you were taking a multiple choice test, your answer should be between 180 and 270, right? But now we have to find out exactly what it is. So again, I'm going to do like before. The tangent of theta is equal to my y over my x, sine over cosine, vertical over horizontal. So my vertical is -4. My horizontal is -7. And a negative divided by a negative is a positive. So I'd have tangent of theta equals 4 over 7. So it's going to come out positive. But that's not on my unit circle. So if it's not on the unit circle, we have to undo tangent. So you remember undoing tangent, the inverse tangent? Remember the tangent with the little -1? So we're going to do that on both sides. So if it's not something on your unit circle, we're going to use inverse tangent, because inverse tangent and tangent undo each other, and theta will now be by itself. So then I go on my calculator, and make sure that you are in degrees. So go to your mode, maybe just put a reminder here in your notes in general. When we're working with vectors, make sure we're in degree mode. Alright, we want to be in degrees right there. Alright, then I'm going to do the inverse tangent of 4 divided by 7 and close out my parentheses. And I'm going to round to the 10th place. And so theta is 29.7 degrees. Is that right? No, because where's 29.7 degrees? It's in the first quadrant, right? That's 29.7 degrees. Well, because think about it. Tangent is positive in quadrant 3, and tangent is positive in quadrant 1. And the inverse of tangent has a restricted domain. So this is my reference angle. So if this is 29.7, but I want to get to this guy over here, I'm going to take my 29.7 degrees, and what do I need to add to it to get to the third quadrant? I need to add 180 degrees. Adding that 180 degrees to get the third quadrant, to get quadrant 3. You will not always add 180 degrees to everything. That's why you want to sketch it first. You know you're in quadrant 3, not quadrant 1. And so that is going to then add up to be 209.7 degrees. Alright, so we're going to take a pause from note taking. We're going to spend some time working in IXL. You're going to do lesson U.1 and U.3. Ultimately, you're going to want to get a SMART score of 80 plus. But what I want you to do right now is I just want you to spend 7 minutes on this one. And then I'll tell you when time is up, and I want you to spend 7 minutes on this one. I just want to get you to try both of these. Alright, so now we're going to take a look at vector operations. And we are going to add vectors, subtract vectors, and we're going to multiply vectors by a single number called scalar multiplication. So, I'm just going to jump into examples here. Let's say we have vector v, and in component form it is 5, 0. And we have vector u, and in component form that is 2, -1. Alright, so the first operation we're going to do is we're going to add these two vectors together. So if I want to do vector v added with vector u, all I do is I add the corresponding components together. So I take the 5 from vector v and I add it with the 2 from vector u. So I take the horizontal component and the other horizontal component and I add them together. And then I take the vertical component and the other vertical component and I add those together. And so my resultant vector, we call it a resultant vector, it's the result that you get, would be the vector 7, negative 1. That's it. Alright. Now let's say if I wanted to take vector v and I wanted to subtract vector u. Well, the process is the same. I take my horizontal component, 5, and I subtract my horizontal component of 2. Then I take my vertical component of 0, and not a comma there, I subtract my vertical component of negative 1. Horizontal minus horizontal, vertical minus vertical. And then my resultant vector, 5 minus 2 is 3. 0 minus negative 1 is 1. So that's how we add and subtract vectors. Alright. Scalar multiplication is really just like distributing. So if I wanted to do 3 times vector u, all I do is I take that number 3, I multiply it by the horizontal component, so 3 times 2 is 6. And then I take the number 3 and I multiply it by the vertical component. 3 times negative 1 is negative 3. That's it. It's like distributing. Alright, so then we want to get to where we're going to put some of these together. So, if I was going to do 2v plus 5u. So I'm going to do my scalar multiplication first. So if I take vector v and multiply it by 2, I'm going to get 2 times 5 is 10, and 2 times 0 is 0. And then I'm going to take 5 and multiply it by vector u. So 5 times 2 is 10, and 5 times negative 1 is negative 5. And then after I've done the scalar multiplication for each one, now I'm going to add these two vectors together. So horizontal and horizontal, 10 and 10 is 20. Vertical adds with vertical, 0 and negative 5 is negative 5. That's it. Does that seem easy? And again, you'll be able to practice that and get better at it, but the concepts are pretty easy. Alright, now the last thing we're going to do is going to be to find the components if you're given the magnitude and the angle. So, find the components. So again, when we say components, we're talking about the pieces, the horizontal piece, the vertical piece. So the magnitude of vector v is equal to 10, and the directional angle is equal to 300 degrees. And we want to find the components. So the very first thing we're going to do is we're going to sketch it. So I'm going to come make an XY coordinate plane. So I know that I have an angle of 300 degrees. So I know that that's down in my fourth quadrant, right? All the way around is 360. So it's 60 less than that. It's about there. So this is my angle. This is my theta equals 300 degrees. And then I know that the length of this vector is 10. So if I need to know the components, I'm trying to find the x and I'm trying to find the y, right? I'm looking for x and y. I'm looking for my horizontal component and my vertical component. But that's a right triangle, right? So if it's a right triangle, that means SOHCAHTOA works. And all my relationships work. So I know that the cosine of theta is equal to x over 10, adjacent over hypotenuse, SOHCAHTOA. And I know that my sine of theta is y over 10, opposite over hypotenuse, SOHCAHTOA. And I know what theta is. Theta is 300. So cosine of 300 equals x over 10. Sine of 300 equals y over 10. So if I want to know what x is, I multiply both sides by 10. If I want to know what y is, I multiply both sides by 10. So x is going to be 10 times the cosine of 300. So 300 is on my unit circle. So get my handy dandy unit circle. Go to 300. Cosine is 1/2. So the cosine of 300 is 1/2 from my unit circle. 10 times 1/2 is 5. Okay, my y is 10 multiplied by the sine of 300. So again, I go on my unit circle. 300. The sine is negative square root 3 over 2. Still is 10 divided by 2 is 5. So negative, that's a negative sign there. Negative 5 square roots of 3, that's y. So then if I'm going to write vector v in component form, say vector v is 5, negative 5 square roots of 3.